Once again, I'm going to begin with taking a look at the graph and finding out how many minimums and maximums I might be looking for. And this sort of looks like a Nike swoop. Looks like there's one minimum value there at about x equals 1. Let me just zoom in a little bit to that area. Right, at x equals, here's x equals 1. At x equals 1, it looks like it's got a minimum value right there. And then this natural log of 0 is undefined, so this is actually a vertical asymptote. It looks like it's hitting right here, but x equals 0 is actually a vertical asymptote, so that is not a minimum or a maximum. Looks like x equals 1 is going to be it. Now, to find out if that's true, take the derivative, and the derivative of x is 1. The derivative for the natural log of x is just going to be 1 over x. Notice that this does not exist when x equals 0. In general, that's something you always need to watch out for. Where does the function not exist? Because it could be that you've got something like this, so the derivative does not exist there, and yet that would be a maximum value. For us, the x equals 0, as I was just explaining, is actually an asymptote, so that's someplace where the derivative does not exist, yet that's not going to be a minimum or a maximum because the function keeps going up forever. Then it does its Nike swoop, and all we have is a minimum. I didn't notice that was off. There you go. Okay, so you just always have to keep in mind when the derivative doesn't exist, it could be that you've got a maximum or a minimum, or it could be someplace where the whole function is undefined. Next up, set the derivative equal to 0 for the horizontal tangent line. So if I move the 1 over x to the other side, it becomes positive. And then cross multiply, and we see, sure enough, x is equal to 1. So then we would have, what's the value of the function when x equals 1? And so it's going to be, well, the natural log of 1 is 0, so it's going to be 1 for x and 1 for y. And so we have a minimum at 1, 1.